Hi friends, in today's lecture, we will talk about a very common function, the logarithm function, what exactly it stands for, and how we can work around with this function, why we use it. Multiplication could be seen in two ways. For example, say we are looking for 81 multiplied by 243. Now, I know that 81 is 3 to the power 4 and 243 is 3 to the power 5. Hence, you can process this multiplication in two ways. You can either directly multiply 81 and 243, or else you can make use of the concept of adding the powers when the base is same. If you multiply the numbers directly, so you're doing 81 into 243 by use of the calculator, as I did, you can find out that this will be 19,683. Or else what you can do, since the power is 4 and the power is 5 here, but the power is of the same base 3. So I can just add up the power and I can say this is equal to 3 to the power 4 plus 5. That is 3 to the power 9, which will turn out to be the same number, 19,683. But the visualization is a little different there. I have directly multiplied and here I'm seeing the power of base 3. You must be thinking, why are we talking about it? Because logarithm is a direct link to this concept where we are talking about exponents, powers. How? Now, actually, what happens with logarithm is that if you want to answer a question, then what should be the power of 3 so that the result gives you 19,683, since I've already mentioned that, your answer would be that, well, this power has to be equal to 9, right? Now, how is logarithm associated to it? So the base is 3. If you take logarithm or log as it's commonly said, log base 3 of 19,683. The answer to this question, that what is log of base 3, 19,683? The answer to this will be 9. So what is logarithm? It's the answer to the question that I asked you here. What is the power of this base which is giving you this result? That's the answer logarithm gives you, and that's the concept of log. So if you've understood this concept, this basically means that since, for example, 81 is equal to 3 to the power 4, therefore, we can say that logarithm to the base 3 of 81 is, what power of 3 gives me 81? 4. So the answer to the logarithm here is 4. So fun fact, another name to this power is logarithm. That's what logarithm is all about. Now let's write it down mathematically, what it essentially means. So suppose y is equal to a to the power x. That implies log to the base a of y is equal to x. Because when you would put a power of x to a, base a, you will achieve y. So this is what is logarithm. Logarithm is another name to power. Now, the base may vary. okay? There are certain common bases that we take, 2, 10, and the most common natural log, which is E. So I'm going to talk about all that. Now, since this is what logarithm means, so we can actually also say that, I'll make you guys understand it with an example. So 3 to the power 4 is equal to 81, okay? 3 to the power 4. 4 is what? We know that log base 3, 81 is equal to 4. So this means 3 to the power 4. 4, I can substitute log base 3, 81 in place of 4 and write it down as 81. So in this equation, if you substitute for the value of 4, write it down in terms of log, this is what an equation, this equation will give you, right? This is a very common way of writing power. Hence, you can have a general result here that a to the power log base a of x will be equal to x. Notice what I've done here is exactly the same thing that you gain from this example, okay? Just written in a more generalized manner. Recall that every positive number can be expressed as a power of 10. For example, if you take 0.0145, that could be written as 1.45 multiplied by 10 to the power minus 2. Similarly, if I change the number to 1450, it could be written as 1.45 multiplied by 10 to the power 3. And there could be various ways of writing these numbers. All I was trying to tell you is that whether you have a decimal number or you have a whole number, you can represent it in terms of powers of 10. That is why originally, for a lot of calculations in the days when calculators were not there, the power of 10 was very helpful and useful. And therefore, the concept of logarithm attached to base 10 turns out to be very important. Though now we do work with calculators, and most often, practically, we use natural logarithm, which I'll be talking about later. But in certain scenarios, for example, the pH value of liquid is a measure of its acidity, and it is given in terms of base 10 log. It's given as log base 10 of 1 upon the concentration of isolated hydrogen ions, okay? This is one of the examples. There could be more such examples for that matter. That's how base 10 logarithms are used. Now, let me give you certain examples how base 10 logarithms would look like. Suppose we have log base 10 of 1000. What does it mean? It means, what is the power of 10 in order for me to get 1000? The power of 10 should be 3. So 10 to the power 3 is equal to 1000. Therefore, the power is logarithm. So the answer to this is 3. Similarly, log base 10, 100 is equal to 2. Log base 10, 10 is equal to 1. So log base 10 of 10 will be 1 because you require the power to be 1 in order to get 10. Now, log base 10 of 1 upon 10. What is the power that you require in order to create 1 upon 10? What is the power of 10? You require 10 to the power minus 1. So therefore, the power that you require for 10 is minus 1. Similarly, what is the log base 10 of 1 upon 100? Now, 1 upon 100 means you have 1 upon 10 to the power 2. That is 10 to the power minus 2. So what is the power of 10 that you require in order to make it 1 upon 100. You require -2. So that's how you can work with logarithm with base 10. Let's look at certain laws associated to the logarithm function. First of all, multiplication. So writing x multiplied by y, that is xy. So it is x multiplied by y. If you write it in terms of power, in the form of powers, see, you remember what we had just learned prior to this is that a to the power log of base a x is equal to x. So if I write x in terms of power, so it would give me with the same base, powers with same base, x multiplied by y would essentially will give me a log base a of xy, and this one is a log base a of x multiplied by a log a of base y. All we are doing is we are using this fact, which we tested with an example as well, that a to the power log base ax gives you x. Okay, so this is what it is. Now, what do we know about exponents? We know that if the base is same, I can add the powers. So I can write this right-hand side expression as a to the power log base ax plus log base ay, which essentially tells you your left-hand side is a to the power log base axy, and your right-hand side is a to the power log base ax plus log base ay. If the powers are same, when can this number, left-hand side number, be equal to the right-hand side number? The base is same. Hence, the powers will have to be the same. So therefore, if the powers are same, then only these numbers could be equal. Left-hand side could be equal to the right-hand side. So therefore, log base a of the product xy is nothing but log base a of x plus log base a of y. Hence, this becomes your law of multiplication in logarithm. So when you're multiplying, when you're taking log of a product, it turns into sum. Second law is of division. Well, clearly, in case you're talking about division, that means you are talking about log base a of x upon y. The moment you will change the products x into y to the product x into 1 upon y, what's going to happen? You are looking at 1 upon y. So here, this is actually x into 1 upon y. So log of base a x upon y will be equal to log a x plus log a 1 upon y. So I can probably write it here itself. So this will be, according to the multiplication rule itself, we can say that this is log base ax plus log base a 1 upon y, which will be equal to log base ax plus log base a y to the power minus 1. And since you have y to the power minus 1, what will it turn into? It will turn into log base ax minus log base a y. Next rule about power 0. So essentially, we all know that a to the power 0 is equal to 1, right? If you take any base, if you take any number and you put the power 0, you will get 1, right? So in terms of logarithm, that means log of base a, 1. What is the power of a? That gives you 1. The power will be 0. So log, no matter what the base is, log of 1 is 0. Next, let's talk about indices here. Indices as in, so suppose we have x to the power n. Now we know that x to the power n is equal to x multiplied by x multiplied by x, so on and so forth. And you're multiplying it by x again, n number of times, right? So that's what is x to the power n. Therefore, if you take log, you're talking about logarithm of x to the power n is equal to, by the first law of multiplication, it's equal to log of x plus log of x plus log of x plus so on and so forth, log of x. How many times are you adding log x? You're adding it n times because you were multiplying n times. So therefore, this becomes n times log of x. Okay? Take a note of something. Here, n could even be a non-integer. Then also this property is true. Let me now give you an example here. What is the solution for 2 to the power n equals to 1000? Let's take logarithm on both the sides. So I know it's going to be log base 10 2 to the power n is equal to log base 10 of 1000. Well, this left-hand side becomes n log base 10 2 equals to log base 10 1000. That means your n is equal to log base 10 of 1000 upon log base 10 of 2, which will turn out to be log base 10 of 1000 is 3 clearly. You will need the calculator to figure out log base 10 of 2. That will be 0.301. When you will divide 3 by 0.301, you will get approximately 9.97, or if you want to stretch the decimals, 9.9667, etc. So you can carry that on or approximate it to 9.97. So what I meant in previously with the index is that this n could be any non-integer as well. You don't have to just think of integers out here. With this much knowledge, can you state what will be the value of log of nth root of x? Well, log of nth root of x would mean that we are taking log of x to the power 1 by n. And hence, by the rule that we did, by the law that we did, 1 by n comes out here and log x, right? Now, there's a logic behind it because, see, what we can say is that if I multiply nth root of x by itself n number of times, if I multiply nth root of x by itself n number of times, I'm going to achieve x, right? Now, by the rule that we have done before, you're doing it n number of times. So you're basically, if you take log, you will get that it's nothing but n times log of nth root of x. Because if you take log, you're just adding each. So you're adding n number of times. So n times log of nth root of x, which will be equal to log of x because you are taking logarithm on both the sides. Automatically, that gives you that logarithm of nth root of x is equal to 1 upon n. The left-hand side n goes down here, log x. And which directly also from the previous law, you can figure out that whether it's 1 upon n, then also it's going to be true. So for roots also, you get this result. Now I'm going to talk about the standard bases. There are two standard bases that we generally use. So one is your base 10, and the other one is base e. Now, what is this e? E is the exponential constant. If it's written just log, then you assume that the base is 10. So mostly when the base is 10, we do not write any 10 generally. Just log is provided. And when it is to the base e, it's written log e, or we also call it natural or Neperian log. So hence ln is written for it. So as I said, e stands for exponential constant. It has a constant value, which is equal to 2.718. This number is just like the number pi. It has an infinite decimal expression, okay? So this is an approximation of this number, e. Couple of useful keynotes from here. Whether it's written log 10 is 1, because this basically means what is the log with base 10 of 10. That's, of course, what is the power of 10 that you require? 1. Similarly, the natural log. So what is ln e? This means that ln means that the base is e. So what is the power of e that you require in order to get e? It's 1. So these are the two important points here. Finally, let's try to use logarithm in order to solve certain equations. So first example. So suppose we have to solve for 3 to the power x equals to 5. Now your variable x is in the power. How to go about this question? When the variable is in the power, what is helpful? Let's take log on both the sides. So we will take log of 3x, and that should be equal to log of 5. You can write log of 3 to the power x as x of log 3, and right hand side remains the same. Hence, x turns out to be log of 5 upon log of 3. And to solve this, we would require a calculator in order to find out the value for log 5 and log 3. But this is how you can make use of logarithm in order to solve equation. Let me take another example. So let's just tweak this one. Let's now solve for 3 to the power x is equal to 5 to the power x minus 2. So this means I have actually x on the left hand side also and right hand side as well. So let's take log on both the sides. So that means log 3 to the power x is equal to log 5 to the power x minus 2, which means I have x log 3 equals to x minus 2 log 5. Okay. Now this means we get x log 3 equals to x log 5 minus twice of log 5. Right? In other words, I can say that x log 5 minus x log 3 is equal to 2 log 5. So what I've done is I've just taken on one side the entry which had no x in it, and all the x entries are on one side. So I can take x common. So I can take x common and this becomes x log 5 minus log 3 is equal to twice of log 5, right? In other words, what do I have here? Now, log of 5 minus log 3 by the rule or law of logarithm, I can write it down as log of 5 upon 3, which is equal to 2 log 5 here, right? So what can I say about x? X is equal to 2 times log 5 upon log of 5 by 3. Again, we would require the calculator of logarithm to finally find out the answer. But this is how you will process such a question in order to find the value of your variable.